Hello, and welcome to Watch My DC Automata Solution demo. Before we start the demo, we will explain Watch My DC licensing, so you will understand which features are in use in this demo. Watch My DC ingests any alert, originating from any third-party observability and monitoring tool through webhook or syslog. This includes also to Watch My DC Lens Observability Solution, which is a native observability tool for those enterprises who are going to adopt cloud-native observability solution in near future. Watch My DC also integrates with most of the industry-known IAC, infrastructure as a code, and RPA, robotic process automation tools. The list of integrations is growing and updated all the time. Watch My DC also offers Watch My DC Automata Solution, which is a native IAC platform powered by Ansible to integrate with any third-party observability, IAC, and RPA tool. Customers need to license the Watch My DC Freedom solution. With the Freedom solution, there is no need to replace existing and deployed toolsets. Watch My DC Lens solution is offered as an independent license. Watch My DC Lens is upgradable to Watch My DC Automata. And with Automata and Lens together, a customer can perform better observability and automations. In this demo, we will present the Watch My DC Automata solution, featured along with the Watch My DC Lens. We have added the required systems, services, credentials, and required playbooks to the Watch My DC dashboard prior to starting the demo. On-premise server with IP address 10.10.10.28 and one AWS account is now integrated with required roles and policies to control the EC2 instances. We have two objectives in this demo. Objective 1, if the local Ubuntu server 10.10.10.28 is unreachable and out of service, then we start the AWS EC2 instance. Objective 2, this is a reverse process of demo Objective 1. If the local Ubuntu server is back online and is in service, then we stop the AWS EC2 instance. And now we all are ready. Let us start the demo. At the very beginning, we will check if the Watch My DC collector status is healthy and online, since this is crucial for on-premise system reachability. Next, we will verify whether the on-premise Ubuntu server is online and functioning. This is the same server as shown in the previous slide. Verifying ping response ensures the system is reachable. Though we are not testing the application and services status here, but we will cover this on our next demo. An Amazon Web Services account has been integrated with Watch My DC through access key and secret key mechanism. User can integrate through role delegation process as well. Customers can add required services to monitor and engage automation by simply listing the service from here. The added service can be monitored from the observability section under Cloud Services Monitoring. No metric information is seen here since the added EC2 instance is at shutdown state. We can verify the EC2 instance status from AWS Management Console as well. We are moving into the automation section now. Here we can see the required inventory file is added named AWS and the required project is named as AWS EC2 demo. We can see two playbooks here. These playbooks will be used in this demo. Moving into the Action Center where the action rules are created. This rule has been created to trigger the action as soon the server seen offline, and the availability falls down less than 80%. We are calling this severity as emergency. Notification will be sent to the Slack configured channel. Time to engage the automation actions. A playbook named EC2 Start will take action to fire the AWS EC2 instance as soon the Ubuntu server is seen offline. As a reverse action, when the local Ubuntu server is seen back online, the AWS EC2 instance will be stopped. Customers have option to choose various notification method from the configuration center, next the app synchronization page. In this demo we have shown Slack notification method only. Time to shut down the on-premise Ubuntu server. Logging to the target Ubuntu server through Secure Shell Terminal. This is the exact same server we want to force shut down. We issue the OS termination command from the CLI. Server gets shut down. We go back to the observability section to verify that the server does not respond anymore. The status still shows online, since it takes a minute to notify the dashboard that the server is unreachable. But if you notice that the ping doesn't work anymore, we move to the alerts dashboard. This is the WatchMyDC Unified Log Analysis tool. We wait here for the incident alert. We also wait to see the Slack notification to be seen in the configured channel. It may take time sometime, depends on the action rule configuration. Example, for the availability check of 40% it takes 3 minutes. WatchMyDC polling frequency is 1 minute. Here we go. The Slack notification has been sent from WatchMyDC stating the server availability is below the threshold. Here we can see 2 events has been generated. First, the emergency event stating the monitored system is down, and second, that the playbook has been executed as configured in Action Center. We move to the AWS Management Console to verify if the server has been started. Here we see that the server is at running state. So our first objective of demo is fulfilled. Now, we move back to the virtual environment where the on-premise server is located. We start the server. The Ubuntu system boots and gets online. We move back to the alerts dashboard, and wait for the new event which will resolve the previous event. And here we go. WatchMyDC sends the notification on the Slack channel. The alerts dashboard has the new events. The previous incident alert gets resolved since the server is back online. Here is the another event stating that playbook has been executed to stop the EC2 instance. It sends the shutdown event for the AWS EC2 instance. We check back from the AWS Management Console that the server has stopped. So the second objective gets fulfilled too.